Hi guys, welcome to 12.4, dividing rational expressions. We're going to try a slightly different approach to filming today's video, and we're going to see if this one works a little bit better for seeing things. So we're on page 660, divide rational expressions. Recall that to divide a rational number expressed as a fraction, you multiply by the reciprocal of the divisor. You use the same method to divide rational expressions. So for example 1, I'm going to sit on the ground. So for example 1, we're told to find the quantity 5x squared over 7 divided by the quantity 10x to the third over 21. So I'm going to do my best to write it out where you can still see it. So example 1, we have 5x squared over 7 divided by 10x to the third over 21. Now what they just said, to divide means you multiply by the divisor, it's reciprocal, so we have to flip this and then turn it to multiplication. So our problem really just becomes 5x squared over 7 times the reciprocal of our divisor, so times 21 over 10x to the third. And now we can do our cross cancellations. 7 goes into 21 3 times, so turn 21 to a 3, 7 becomes a 1. 5 goes into 10 twice, so 10 becomes a 2, 5 becomes a 1. X squared goes into x to the third, one whole time, leaving behind just a single x. The two x's got canceled out by these three x's, and now you just multiply straight across. So you have 1 times 1, which is 1. 1 times 3 is 3. So our top, or our numerator, is 3. Now I have 1 times 2x. 1 times 2x is just 2x. So after we divide, and again we divide by multiplying by the reciprocal, our final answer is just 3 over 2x. Let's look at example number 2. Find or express expressions involving binomials, third time's the charm. So we have example 2. And we have the expression n plus 1 over n plus 3 is then being divided by 2n plus 2. And right away you should see you have a GCF of a 2 that you can pull out of these. And then n plus 4. So step 1, since we're dividing, we need to multiply by the reciprocal. Always, always, always just kind of start by rewriting it so you know what you're working with. You have n plus 1 over n plus 3 times, not 2n, see? Whoop. That's where you can already start to make the mistake. Times the reciprocal, n plus 4 over 2n plus 2. Alright, now I'm going to pull a GCF out of that, and I'm just going to rewrite. I'm rewriting right here. So I have n plus 1 over n plus 3 times n plus 4 over, pull out my GCF of 2, 2 n plus 1. And now I can start to look, do I have anything that cancels out? I have an n plus 1 that can cancel out, both on my top and my bottom. This is going to become a 1, and this is going to become a 1 when it comes to multiplying. So now I have 1 times n plus 4. Anything times 1 is itself, so I just have n plus 4 in my numerator position now, over 2 times 1 is 2, so my second one right here is just 2. 2 times n plus 3, so 2n plus 3. You can leave it as that, or you could distribute it back in and have n plus 4 over 2n plus 6. Either way, there's my final answer for example 2. Alright, now we're on the top of 661. Often the quotient of a rational expression involves a divisor that is a binomial. So let's look at example 3 and see what they're talking about. So example 3, divide by a binomial. Example number 3, we have 5a plus 10. Again, right away you should see you have a common factor of 5 that you're going to be able to pull out of that, or a GCF. 5a plus 10 over a plus 5 being divided by the quantity a plus 2. Right away, you know this needs to be put over a 1 because anything by itself is really just over 1. And now you're going to see how that's important when it comes to flipping it. Because we're dividing, that means we're really just multiplying by the reciprocal of our divisor. So that means we have 5a plus 10 over a plus 5 times the reciprocal of our divisor, 1 over a plus 2. And remember what I said, you should see right away that you have a GCF of 5 here. So if you pull out your 5, you're going to have 5 times the quantity of a plus 2. And now you see you have some canceling. You can cancel out a plus 2 top and bottom, and you're left with 5 times 1, which is 5. 5 times 1. This is now a 1 as well, over a plus 5 times 1. Anything times 1 is itself, so a plus 5. And that's your final answer. So if you're given a binomial just by itself, don't forget in your first step, put it over 1. That way when you do the reciprocal, it becomes 1 over your binomial. Sometimes you must factor a quadratic expression before you can simplify the expression. So let's look at it. Example number 4. Oops, that's an X, and that needs to be an A. Example 4. We have the expression m squared plus 3m plus 2. So m squared plus 3m plus 2 over 4 is then being divided by m plus 2, m plus 1. Because we have a polynomial, we know we have to factor it. 3 is positive, 2 is positive, so both of my factors are positive. 2 is easy, my only factors of 2 are 2 and 1. 2 times 1 is positive 2. 2 plus 1 is positive 3. So this is going to factor as m plus 2, m plus 1, all over 4. And because it's division, I need to multiply by my reciprocal. So m plus 1, m plus 2. Right away, I can cancel these out. And now I'm left with something interesting up top. I have m plus 1 times m plus 1. Well, m plus 1 times m plus 1 is just m plus 1 squared. This became a 1, so 4 times 1 is just 4. So my simplified expression is m plus 1 squared all over 4. And we're going to stop there. You're welcome to look at example 5 yourself, but as I don't have a calculator with me, we're going to skip that for right now. It's all about conversions, so it could be fun for you to try. But that is 12.4. You are welcome to start your homework now.